everyone. Great to be here to moderate this panel session on mine electrification and its impact on strategic mine planning, to tie into the theme of this symposium. As John highlighted in his talk today, decarbonisation is a big theme in the industry at the moment. And once people have got through converting to lower emissions renewable power, mine electrification is the obvious next step to take it to take that into the mine. And at its core, electrification in mining is about replacing the diesel that's consumed in the mining process, which is mostly from truck haulage using traditional equipment, and replacing it with alternate sources of power. And this can be done with a whole bunch of different technologies, some of which have been around and implemented for decades. They're nothing new, but I guess getting reevaluated and perhaps increased in interest now. And some other technologies that are really emerging and evolving, and we're all learning about all the time. So the key ones that we're going to talk about today, we're going to look in for open pit. We're going to be talking in pit crushing and conveying, trolley assist, and battery electric vehicles. Gosh, I'll probably say that a few times wrong. And for underground, we're largely talking about battery electric vehicles, conveying, shaft hoisting, etc. And in discussing these technologies, we're going to focusing on the infrastructure, equipment, and planning impacts that these electrification technologies have. And they're all a bit different. So they all get applied to different situations for different mines for different purposes. And we're hopeful that with the panel here, that maybe out of this is, because it's something that we're all learning about a bit, right? Because it's changing the way that we plan, and sometimes the way we need to think about planning. So I'm hoping that some of the insights that we get out of this panel session, you might be able to go away and change the way a little bit about what how you do your planning going forward. At the end, we kind of want to make this a bit interactive, so we do have some people in the audience who we might call on. I'm not going to mention any names. It could be you. To get involved. But if you've got any questions or comments, there'll be a time for us to ask those. So please note those down, and we do definitely welcome those and welcome your insights that from your experiences as well. Joining me on the discussion, we've got a great panel here. So firstly, we've got in the middle, we've got Gavin Mann, who's a principal for mining technology at South32. Gavin has over 20 years of experience in mining operational and technical roles, skills including strategic planning, risk management, studies, operational management, business improvement. Gavin has hands-on experience in gold, nickel, copper, zinc operations, specialising in managing deep, narrow vein style deposits in challenging ground conditions, and in his recent roles with Goldfields South32 has been focusing on electrification of underground mines and automation. So a great addition to our panel. Please welcome Gavin. We need claps to encourage us to continue on towards drinks. It gets us closer. So at the far end, we've got Phil Morris. He's an independent mining consultant and associate at Snowden, Optiro. Phil has over 50 years of experience in open pit mining.
Thank you for saying that so quiet.
Doesn't look it.
51.
51. Is it 51 or 52 now?
52.
Yeah, 52. Okay, sorry, I shortchanged you. Including 25 years in large pit, open pit precious and base metals operations with Rio BHP in Placidome in a range of technical managerial roles in Australia, Papua New Guinea, South America and Africa. 4 years as general manager, CEO of an international mining contractor in Ghana and Tanzania, and then 17 years as an international mining consultant, focusing largely for the last 15 or so years in pit crushing and conveying. So please welcome Phil. Last but not least, we've got Sarah de Vries, who has recently joined us at Snowden Optiro as a principal consultant focusing on mine electrification. Sarah has over 15 years of experience in mining operations, planning, consulting for both open pit and underground mines in Australia and Africa. Her particular focus is on mine electrification, and she has 4 years of experience operating and design for a diesel electric trolley assist operations in Zambia. 6 months of experience with Fortescue assessing electrification options, including trolley assist and battery electric vehicles. And most recently, she was involved in the Cosmos underground electrification study for IGO, assessing technical and financial feasibility of converting the Cosmos mine plan from diesel to battery electric. In addition to a couple of Julian and Robin and maybe others who were involved in that study also. So please welcome Sarah. Before we kick it off, just want to say the standard disclaimer that each of our panelists are providing their own views and opinions during this session, don't necessarily represent the views of their organisations that they represent, so they're free to say whatever they like. So with that being said, we'll kick it off with we'll start with a bit of an overview of the various technologies before we get into the detail. So maybe we just start, Phil, with open pit, and you could explain what in-pit crushing and conveying is about.
Sure. We were around. IPCC as in-pit crushing was around before the Plenary Commission on Climate Change and all the rest of it. So we have the original IPCC. In-pit crushing and conveying is essentially a means to cut down your long hauls and replace trucks, because conveying is much more efficient means of transporting material than with trucks. In-pit crushing essentially exists in 3 forms around the world. There are over 500 operations worldwide that are using forms of in-pit crushing, but you can have an ex-pit crusher, which is traditionally located somewhere as close as you can to the pit rim with external conveyors. A semi-mobile in-pit system, which can either be located and moved once every few years or can be moved on a more regular basis depending on the nature of the crusher system. And fully mobile systems, which lend themselves to a continuous form of mining, most simply like in a coal mine where you've got a high wall mine, where the whole system, everything is done with the in-pit crushers and loading system, and there are no trucks whatsoever. So perfect solution for IPCC is fully mobile. Doesn't happen very often, and you work your way backwards from that. 2 types of crushing, of course, is that you're trying to crush ore and as well as waste. We all crush ore because we've got to get it to the plant and reduce size comminution, but traditionally now, as metalliferous prices in particular get higher, the strip ratios of our mines go up in open cut environments, and so we're usually mining waste before we're mining ore. And when you've got large tonnages of waste, it lends itself to in-pit crushing and removal of the waste to an external dump. The problem is that all the crushing costs for waste is dead cost, whereas for ore you're already going down that path no matter whether you use IPCC or not. I think that's enough, I suspect, for now. Thank you.
Perfect.
Yeah.
Maybe we move to Sarah. I'll talk about trolley assist.
Hi everyone, thanks for coming today. Trolley assist is a very well developed technology that's been in use for over 50 years. A diesel electric truck is required to use trolley assist. A diesel electric truck uses a diesel generator to drive the electric wheel motors which propel the truck. When the truck is underneath the required electrical infrastructure, the truck raises its pantograph to connect to the overhead line, or the OHL. Electric power is then drawn directly from the OHL to power the electric wheel motors and propel the truck. The diesel generator is disengaged and the truck runs on electric power. Once the truck reaches the end of the OHL, the pantograph is lowered and the truck reverts to diesel power. Traditionally, trolley assist has been used on ramps in pits or underground, where significant diesel and cost savings can be achieved, as well as a substantial speed increase, up to double.
Great. Maybe you can continue on.
Okay, sorry, you're going to get sick of me talking, but I won't talk at the end. Electric excavators and rope shovels. Tethered rope shovels or excavators have been around for a long time. Rope shovels are pretty common in WA. Backhoe excavators not so much, and that's generally due to the requirement for significant electrical infrastructure. Diesel is easier and provides more flexibility. A major innovation in the last few years is the addition of automatic cable reelers to minimise the manual handling of cables and allow faster and simpler relocation of the excavator. This is also a great innovation to stop the cables getting run over, and I won't tell you where I've seen that happen. Moving on to battery electric trucks. Battery electric ultra-class trucks are a very new and still developing technology. It's only recently that battery technology has advanced to the point that powering an ultra-class mining truck has become technically feasible. With this technology, a lithium-ion battery replaces the diesel generator in a diesel electric truck. It's a much more flexible solution than trolley assist, with the same benefits of completely removing diesel consumption, as well as the speed increases on the ramp. It also means that the power generated during braking can be stored in the battery instead of lost as heat. Free power. It still requires significant infrastructure to set up battery charging stations, which are required far more frequently than diesel refuelling. For example, you may only refuel a truck with diesel once or twice a day. You will need to, with current technology, need to recharge at a charging station every 4 to 6 hours, depending on usage. Please forgive me reading my notes. There's a lot of information and I don't want to miss any of it for you.
I guess that's going to be something that we're going to talk a little bit more detail about later on as well. In terms of underground, the concepts are quite similar, I guess. The focus on, but just a different application, right? So.
Underground we're looking at battery electric loaders and trucks, as well as ancillary and light vehicles. Tethered electric loaders have been around for decades. However, they haven't been very flexible and they're generally used in stationary operations such as block caves. Battery electric trucks and loaders have been developed over the last 5 to 10 years, mainly in Europe and Canada. And they are much smaller than their open pit equivalents, and the technology is therefore further advanced. The smaller size has allowed the concept of battery swapping to be developed, where instead of parking up a vehicle for some time to charge it, the entire battery is swapped out for a freshly charged battery. This allows the vehicle to remain in productive use longer, with typical battery swap times ranging from 5 to 20 minutes currently. It also allows the depleted battery to be charged at a slower rate, thus extending the life of the battery. Currently, decline truck haulage on a single battery charge is limited to several hundred vertical metres. Decline hauls of more than that will require multiple battery swaps, which is challenging logistically. More traditional options such as shaft hoisting or conveyor transport, or passes, or a combination are more appropriate at the moment for deeper mines.
Perfect. Okay, no, that's great. And so I think that gives you an overview of some of the things that we're going to be talking about in the context of strategic mine planning. I guess each of those particular technologies we're doing for a reason. We're doing to generate some benefits, whether it be economic, environmental, safety. So it's not just about, one thing I would say is it's not just about the emission savings that we're going to get through this. There are other benefits that we're driving through this. But maybe, Gavin, you can kick off by talking about some of the benefits that we're trying to drive in the underground space.
Thanks, Tarrant. Look, I think the discussion on benefits is pretty well advanced these days, and there's a wide range you can choose from in your ESG or productivity or financial toolkit. South32 focused its early efforts in the application suitable underground for a few reasons. The first being that the underground environment offered a smaller scale in which to start to play. And that was also where the OEMs, first started to make inroads into the industry as well, with those smaller vehicles, and the scaling down approach to get a start. We also have signed, I think, as a lot of companies in our tier group have, to the ICMM, so the Cleaner, Safer Vehicle Industry Initiative. That's a good tool to align, I think, a strategy piece around when you're looking at the vehicle interactions, diesel particulates, greenhouse gas emissions. That really gets quite a high level sort of motivation towards the benefits for electrification. And for us in particular as well, at the time we were kicking off a pre-feasibility study, so we were looking at some options. It gave us a chance to participate with some of our like-minded peers and colleagues through the Electric Mine Consortium and get access to other trials that were happening within the Australian market, which was really useful in terms of sharing those learnings of adoption, risk, hazards. That's I guess our next step in terms of what do we do with that range of benefits on offer is trying to narrow them down to the 2 or 3 that create that sense of purpose and get that commitment to delivering the vehicles at scale, moving beyond the trial.
Great, and I guess some of those benefits that we're that we're looking for, maybe could we touch a bit on the ventilation benefits that we get?
Yep, I can talk about that for you. So there are some pretty clear-cut economic arguments for using battery electric vehicles underground. Diesel generation is only about 30% efficient, and a substantial amount of energy is lost as heat. By removing diesel from the underground environment, we can dramatically reduce the heat generated underground and hence the cooling requirements of the mine. So we've got a substantial potential ventilation and cooling saving that we can find there. Additionally, by removing diesel from underground, we can remove diesel particulate matter as well, which creates a much healthier environment for our workforce. And we also reduce the diesel dilution airflow requirements, reducing our primary and secondary airflow, as I mentioned previously. So these both result in significant energy and cost savings. There are other ESG benefits as well, such as removing noise and vibration from the vehicles that we operate underground. This results in a safer environment, particularly for tasks where communication is difficult due to noise.
Excellent. And maybe we can move to open pit. And Phil, you want to talk about IPCC?
Certainly, yeah. Clearly, as we said at the outset, it's all about trying to cut down truck numbers. Over 15 years and 40 studies, I think the average saving of trucks varies between 25 and 50% is what you typically may achieve in a study. Obviously, if you went fully mobile like S11D in Brazil, technically you can remove all the trucks, but it's a pretty major challenge to remove everything. You're going to save, obviously, for every truck you've probably got 6 people you're going to save, 4 as a minimum for operators, or 2 for maintenance. So it's maintenance savings as well as operating savings. So if you've got autonomous trucks, it doesn't negate IPCC. Obviously you've got the diesel and the emissions and the carbon reduction, certainly the on-site carbon emission reduction. You've got to have clean energy to make that flow all the way through the system. You're going to cut down on your CapEx from your truck fleet. And one of the things that gets forgotten a lot is maintenance workshops. Maintenance workshops we've found cost an absolute fortune, and for every dozen trucks you can save, you can make a really major reduction in capital for your infrastructure. The upshot of that is that on the plus side, let's stay with that, conveyors 15% dead weight, 85% live load, a truck about 50%, so you're carrying a lot of dead weight around in a truck, and once you add the efficiency or inefficiency of diesel versus electricity to that, you can see where the crushing and conveying can be enormously cheaper than a trucking operation, but there's some downside that we'll talk about later. And shall I chat about the trolley assist? I mean, obviously, trolley assist, we can do 25 kilometres up the ramp instead of 12 or 13 kilometres quite comfortably. When you're on trolley, you're only idling the engine, so you're using 10 or 12 litres an hour instead of the full engine power, which might be as much as 500 litres an hour or more for a 360-tonne class machine going up a ramp. You're going to cut down the emissions, and obviously if you've got faster trucks, you'll have less of them, and therefore less capex and opex associated with the personnel.
Great, thanks Phil.
Cheers.
And Sarah, do you want to just touch on the...
Oh, yeah, very briefly, BEVs are just an extension of all of that, removing your diesel consumption and your emissions from diesel. Eventual cost savings once the technology advances. Batteries still are very expensive and reduce noise.
Great. So I guess the one question is where have these technologies been implemented? So some of them are much more mature and have been implemented, have been tested, have gone through all the learnings, and some are much newer. So maybe we'll just start on the underground side with the BEVs. And Gavin, can you maybe just share some of the things that are going on and evolving all the time in that space?
Yeah, I think that's a good way of describing it as progression or evolution, Tarrant. I think there's a lot of publicly available information there about who's ordering what, and there's some pretty big orders out there as well, which is really positive signs, I think, for those signals of intent for the various companies. We're not talking ones and twos. Looking at 20s and 30s of equipment, and in the heavy haulage space as well, which is, I think, probably the most ambitious of the the equipment that I think anyway for underground mining is ready to deploy, or has the best place to fit in your mining operating system. The trials that I was aware of as well through the EMC, we've seen the heavy haulage gear in Australia, which is great. The 518B and the Z50 trials that happened at Goldfields, as well as the integrated tool carrier. There was also the 665B at Anglo Ashanti. So there's definitely intent there, to use these machines and to see how they fit in even our existing mines, our brownfields mines, which is always, I think, a bit of a introduces additional adoption risk into a program to electrify a mining fleet. I'll hand it back to you.
You got some others, Sarah?
Yeah, I've got some favourite examples I'd like to share with you from overseas. Canada's way ahead of Australia, although generally with much smaller kit than we use here. Borden Mine was one of the first to start using BEVs underground due to their location next to a town and the need to reduce noise and exhaust fumes. And that's the good old social licence to operate that we keep hearing about. Macassa Mine in Canada, which is where the original artisan truck was developed by Mike Mayhew and his team. That's now the Sandvik gear that we see running around. Well, not in Australia, but in Canada. Vale in Canada has been using electric gear underground in Sudbury for years, again on smaller equipment. And of course, Glencore's Enlarping Depth project in Sudbury, which is an extension of the Craig mine. This mine was economically unviable using diesel due to the amount of cooling required. This was proved in 2 feasibility studies. It was only by going fully electric that they were able to make the project work economically, which I think is such an exciting development. And then, of course, you've got companies in Europe, such as LCAB and Boliden, who are well ahead of us as well and have been trialling BEVs for 5+ years.
Thanks, and if you're interested in any of those examples, just reach out to us and we'll let you know the names of those mines, and you can you can have a look at them online. Phil, do you want to talk to where IPCC has been?
Yeah, it's. I think everywhere is the only thing I could write down here. There's a PhD done in 2012 by somebody who was working for Sandvik that. At that point in time, there was somewhere between 520 and 540 installations worldwide. I think it's probably substantially higher than that in total. But you see, in-pit crushing covers such an enormous range of material types and ore and waste. I mean, you've got tar sands, which you classify as an ex-pit crusher or a style of crusher, but it doesn't require hard rock crushing. Just out of interest, the first in-pit crusher in Australia was at Mount Newman, and that was installed in the 1980s as a fully mobile unit crushing waste, and it failed. But that's a part of the problem, and something that is worth always mentioning other than numbers is that if you're going to use in-pit crushing and conveying, you've got to change the way that you do your mine planning, and it requires a paradigm change from people who like to rely on having stockpiles and poor planning to get them out of trouble. You can't do that when you're using in-pit crushing, I'm afraid. Unfortunately, even if you're mining waste, it's got to be mined in sequence. If it's in front of you, it's got to go. So, but there's endless numbers here. You've got Kanshansi, Sino Iron here in Australia has got ore crushing. There's something like 80, I gather, at the present time in Turkey alone. I know there's plenty in Germany in coal. So just about all rock types, everything from 50 megapascal or lower right up to 300, 400 MPa. But obviously once you get above 100, you've got to use gyratory crushers. So that starts to affect the capital quite dramatically.
Great. That's, everybody crushes and conveys, right? So
Yep.
It's a matter of just how close you bring it. And Sarah, maybe you can touch on the trolley assist examples, which is a shorter list of implementations.
Yes, it is. Trolley assist has traditionally been used in Africa where there's cheap power. For example, Sishen in South Africa and Nchanga in Zambia. This is in the 1980s I'm talking about. In the 2010s, there were several mines in Zambia using trolley assist, Lumwana, Kansanshi and Sentinel mines. Kansanshi and Sentinel are both still using trolley assist. Lumwana are looking at starting it up again as part of this super pit expansion. Cobra Panama also was using trolley assist until that mine was shut down about a year ago. In the last 5 years or so, trolley assist has gained popularity as a means to reduce carbon emissions. You've got people like the Leiden, their Aitik and Kavitsa mines, as well as Copper Mountain in Canada, have all trialled and implemented trolley assist on ramps up out of the pit or up to the waste dump. So trolley assist has really regained popularity in the last 5 or so years for a different reason that it was invented in the first place. Battery electric trucks are still very much at the prototype stage. Fortescue have been testing their battery-powered Liebherr truck in the Pilbara, and Caterpillar are now testing their early learner BEV prototypes with BHP in the Pilbara and with Newmont at Cripple Creek and Victor in the US. Both of these models will utilise static charging, where the truck will need to be plugged in frequently to recharge the battery. Trolley assist is now being considered as a means to not only power diesel electric trucks, but also as a means of dynamically charging battery electric trucks. There are several other dynamic charging systems being developed as well, which is similar to trolley assist, but with reduced and more flexible infrastructure requirements. For example, Blue Vein, Caterpillar and Liebherr have prototypes coming onto the market, and we'll talk a bit more about that later.
Yeah, it's really interesting how technology from 30 or 40 years ago is being repurposed to help, solve the technical problems that we've got, or challenges that we've got in another area. So that's where they are applied. I guess if we could then maybe condense it down to they're applied to different situations, right? So it's the technology, it doesn't work for all mines, and we need to figure out where it would be most appropriate. So maybe we can just step through each of those and talk to what types of mines or what geometries or whatever would suit the implementation of those technologies. So maybe Phil, do you want to kick it off?
Sure. Couple of golden rules. I suppose it's wonderful if you've got a great low power cost wins all the time. So anything where you've got to generate your own power on site by whatever means, if you can't compete with the 4 cents Canadian for hydro that you can get in northern Canada, it's never quite as good. Numbers should always look good with low power costs. You're looking for mines for in-pit crushing that generally have high volumetric movement, high tonnages on an annual basis, or waste, doesn't matter. A lot of material needs to go to the same point, so either the ore needs to be going to a crusher, or you're heading for a substantial waste dump where you can use spreader technology that gives you very, very low costs of deposition of your waste material, rather than having to build it in little layers. So all the costs with IPCC comes at the decommissioning end of things, where you had to flatten the slopes off, but you can traditionally dump very high dumps with an in-pit crushing system. You don't want complexity of material types. If you've got an ore body that's got 4 or 5 types of material that you've got to blend, or you've got a mix of waste that require encapsulation, all of that, making donuts and things like that for your waste dumps, gets difficult when you want in-pit crushing. We like to keep it simple as much as possible. It lends itself to anywhere that has got not more than 3 or 4 material types if possible, and long haulage distances obviously is the only other criteria that you're looking for, because haulage distance equals truck numbers equals people and carbon emissions. So trolley assist is probably much of a muchness in that you're looking for deep mines, but I think there's an issue really with the amount of trucks that you can put onto a single line because of the substation size. So I don't know whether we're going to discuss that separately, but I know that's always been an issue. Every time we seem to get a good run at a trolley, we need 8 or 10 trucks on the line, and it's like, whoops, where are we going to get the power from? So
we did do it at Kansanshi. We got 8 trucks on one line.
You got 8 trucks.
Yeah, but we had double the electrical infrastructure.
So long as the mill wasn't running at the time.
As long as Sentinel was having commissioning problems.
Okay.
Yeah.
You can't really handle tight radii very effectively on switchbacks and things. I mean, some few mines have done it, but generally you want large radius curves, or you want straight runs as much as you can. So that affects your mine planning. And I think last but not least, you want your rolling resistance to be absolutely minimal. So you've got to maintain your roads to make them smooth, and good tyre life also goes with reducing power consumption for trolley. Battery vehicles, does one of you want to talk to that? Or I mean, obviously the only thing I can say is laden downhill hauls, great if again you've got this ability to either you can recharge the battery on the truck if you've got laden downhill hauls, or if you've got a pantograph you can actually run power back into a system. And while I think about it, in-pit crushing allows you to put your waste dump miles away from the pit, and if you could get a downhill haul for a conveyor, you can generate power on a permanent basis with in-pit crushing that can be fed back into your circuit for the mill system. And so I think it's a really plus I forgot to mention about in-pit crushing was it takes away the need for your waste dumps to be sitting right against the edge of your pit, particularly if you've got downhill hauls.
Perfect.
Thanks.
Gavin, maybe you could talk a little to the underground.
Yeah, look, I think of the sort of categories you mentioned there earlier in your question, really the only, I think, difficult commodity for battery electric vehicles to find an entry point is, I think, coal mining, with the intrinsically safe nature of electrical systems in coal mines. I'm not speaking from any degree of experience there, or having spent underground, time underground, but that's probably the one commodity that at the moment presents the most challenges in terms of adoption. I think we've already mentioned here, just in terms of from a pure payback point of view, being able to have a vehicle that carries its load downhill is obviously a big benefit for regeneration. That's just a shortcut to charging while you're driving. It's a great advantage that you can build in. And Phil mentioned the rolling resistance piece. there's just subtle little things you can do there just to help take the load off the engine. So even, 1 in 100, 1 in 50, just running it where the vehicle is going to be loaded makes a big difference in terms of that battery life and how that vehicle is going to perform in your mine. LHDs, I think, again, we've talked about how we think those are probably, the most likely first point of or scalability within a mine. That we've already had electric LHDs in our mines, and as Sarah mentioned, there's probably 1,000 foremen out there with that still have nightmares about running over cables and disrupting production. So if you could wave a magic wand and remove the cable and have the machine run, they'd take that in a heartbeat, right? As long as you can figure out how to get the efficient swapping of the energy source for the machine. I've seen them in operation. The way they attack a muck pile is incredible. They're well worth, I think, the deliberate thought for the implementation in order to get the best out of them. Other battery electric vehicles, I think, that are particularly for underground mining. Again, speaking from working in tunnels all my life. Shotcrete sprayers, charge up, all of those ancillary machines, ITs. Just the environment that I think is inherent with working those machines. Electrification is definitely a pathway to making that job a lot more worker orientated or worker friendly. I think that's another one. And then light vehicles, that everyone kind of blinks at and goes, why should we roll out a fleet of light vehicles? I've already got a bunch of cars that can do whatever I need them to do. They're a low cost, low risk point of entry. They're non-production, but they represent the same degree of hazard and adoption and risk that a full-size electric vehicle would take. So if you want to go and roll out your full heavy diesel fleet as a first pass, be my guest. I highly recommend you pick something like a light vehicle to go and play with it first and see how your mining system, your mining procurement, all of the risk process accepts that change and scale up from there. That's been one of the big learnings I think we've had in the last sort of year, 18 months.
Do you think it's fair to say that electrification of underground mines in general has a much broader application to a greater percentage of underground mines than like open pit, which is, I guess, these technologies are generally more focused on larger scale operations? Would that be fair to say?
I think it's just solving for it, right? Like the electrification initially suits smaller equipment. That's where underground mining is. Like, we don't have ultra-class 300-ton trucks driving around underground. That's a big problem to solve for. And some of the technology that they're talking about in terms of mega fast chargers, how they're going to reticulate the energy around site. That's quite eye-opening to see, or to start to understand how that will look in the future. I think for the underground market, it's the perfect size fleet. Even a lot of the road-going vehicles, are easy to learn from. The Volvo trucks and whatnot that they're bringing into to surface haulage. There's a lot of similarities in that scale to what we use underground.
And so, I guess in terms of battery electric vehicles for open pit, one of the challenges we've got is the time. So if you were planning like an underground mine now, you might be able to consider this. It's actively being considered as part of the study. Whereas for an open pit, the technology might just be, a few years ahead, depending on when you're looking to implement. Is that fair?
Yeah, that's absolutely right. There are only two main underground OEMs at the moment with battery electric gear. That's Sandvik and Epiroc. They do still have quite long lead times for battery electric gear for underground. We're looking at anywhere from 18 to 24 months at the moment, if they show up when they're meant to. But they are at least out there and they are being used, and obviously production capabilities are being ramped up as we speak. I think I read somewhere that 15% of Sandvik's order book last year was battery electric, which is a pretty impressive number. Open pit obviously is at the prototype stage. There are prototypes being tested in multiple places in Australia and around the world, but we're looking at about another 5 years, I believe, until they will be commercially available to everybody, not just the big guys who are getting to play with them at the moment.
And I guess it's looking a bit far into the future, but do we think that in open pit, once these challenges are resolved, that battery trucks will be, widespread on mines of all sizes.
I think they're going to have to be. I mean, diesel is a huge cost, and it's a huge proportion of carbon emissions for open cut mines. It's not probably as important for underground. The proportion of power usage, carbon emissions on a site that comes from diesel haulage underground is comparatively small, but certainly for open pit, the amount of diesel and carbon emissions that come out of the diesel fleet is huge. I think it's about 30%, depending on the mine, obviously. So that's something that obviously has to change, and whether it's a first step such as renewable or biodiesel, or even moving from a fully diesel truck to a diesel electric truck, where you get 25 to 30% savings in fuel efficiency, because that's the technology that's available now, whether it's looking at trolley assist or whether it's planning to eventually move into that battery electric space. I think any mine, particularly with a major mining company, even a medium mining company these days, has to be looking at it, because it is the way of the future, in my opinion.
Absolutely. And so I think, if we look at the types of mines that would suit these technologies, and I think it's fairly broad in the battery space, generally speaking, but much more specific in terms of IPCC and trolley assist. I mean, it's the opposite. So if we're talking about mines that it doesn't work for, if you've got low production, if you've got a high power cost, and particularly for IPCC, Phil mentioned that if you've got complex material types, so that could be if you need to blend ore, right? It's challenging. And if you've got waste, if you've got complex waste management, acid forming materials and whatever, it's difficult to manage, and that might be a thing that excludes it from being considered. And particularly for fully mobile IPCC, I mean, great in theory. In practice, you can never quite get the shapes that you want to make it work as a fully mobile system. At least not we haven't seen so far. So I guess from our experience with IPCC, I mean, it'd take a perfect situation, I think, for fully mobile IPCC to be really a viable option, and you're probably much better off considering semi-mobile or permanent crusher installations in smartly located places to make that work. Is that fair?
I agree with that, but there are a couple of things that are a real hindrance when you do a lot of these studies. Internal discount rates, or whatever you want to call them, internal rates of return and things of that nature, continue to astound me, I think, when I come across studies. And at 15% internal rate of return, it's very hard to ever put anything that you want, because the capital investment for in-pit crushing is always high up front, and the savings are then quite rapid, but without big tonnage and without a realistic discount rate, it's very hard. I mean, I can tell you right now, if any of your companies wanted to look at in-pit crushing, if they've got a 15% discount rate, if you're not going to get recovery of it in 3 years, nobody will ever do it. And so I hate to say it, but that's a fatal flaw in my regard, is that you've got to be realistic about how you discount money looking forward.
Yeah, it's a real challenge, because when you think about implementing one of these systems that reduces your cost, if we put aside the emissions, the need for the emission savings and things like that, when you're looking at something that just saves you cost on $1 per BCM and is not selling more iron ore at $120 a ton, it makes it pretty hard to make a 15% discount rate work, right?
I think you can get more than 15. It's just what there is, the overall value looks like against your initial capex. Yeah.
Which is a good lead on to talking about some of the equipment and infrastructure requirements of these technologies, because generally speaking here, relative to a standard operation, we're talking about more capital for which we get benefits from over time. So there are investments in their own right, Whether some companies choose to assess them in that way or they just choose that they're going to put them in place, that's one thing. But if you actually looked at it in isolation, there is an investment that needs to be made and savings that get generated over time. So maybe Phil, you could just talk quickly to some of the infrastructure and equipment requirements that drive capex. I think is probably
so. Clearly, the equipment in its own right, the crushers, conveyors aren't always the most expensive item, but spreaders and distributed systems and ring mains, you've always got a typical in-pit crushing power requirement can be as low as 10, but as much as 50, 60, 70 megawatts. And it's not that easy sometimes to be able to reticulate that without some significant cost. Usually we've got to then bring that power into the pit if we want to get anything except pit rim crushing, and that makes things more complex unless you've already got a good in-pit system with frangible mast or whatever you're going to use. Capital cost in itself we've mentioned. Usually the reason that people get hung up on in-pit crushing is that a large crusher now is north of just a raw machine, 25 million US or something like that. And by the time you've got all these things built, civil works and all the reticulation, usually a full-blown in-pit crushing system for waste, for example, will be in the order of upwards of 200 million. And so you can buy a lot of trucks for 200 million, so you're going to recover that and reduce your emissions, but you've got to get it as quickly as you can. So long hauls is the key, I think. I think let's keep it short. That's enough. I mean, I've covered several of the points earlier on. I think it goes without saying that your problems are always related to upfront expenditure with in-pit crushing systems.
Yeah, I think the one of the considerations, I guess, in terms of the trucks is that of all these technologies for in-pit crushing and conveying, you can generally use any type of truck, right? Which gives you a bit of flexibility, particularly when it comes to retrofitting to existing operations. And I guess whenever you think about the capex for IPCC, I mean, particularly if you could time it for when you're doing a fleet expansion or buying new equipment, you can use that to offset the capex that you've got to spend.
Perhaps on the point you've raised is we should think about IPCC at the greenfield stage, not so much at brownfields. It's harder to retrofit IPCC into into a mine, but if you've got a clean sheet of paper and you can organise your mine planning to suit the in-pit crushing installations and optimise it from up front, that's the way that you can really make the best inroads.
The same goes for trolley assist as well. If you get a chance to do it up front, for example, you'd like to put your trolley assist in, your trolley ramp in on a final pit wall, and that might change the way you would typically stage your pits. Doing it the typical donut style is not necessarily going to work for you unless you're prepared to move that trolley line as you proceed with the next cutback. That might be okay to do in Africa where the labour is reasonably cheap, but it certainly wouldn't work in Australia, I don't think. So if you can put it in once and leave it there, that's first prize.
And so just continuing on trolley assist, what are some of the major investments and infrastructure required to support that?
I guess there's quite a few. It's obviously not a cheap exercise. You have to buy a DC rectifying substation to provide DC power to your trolley line. That's anywhere from $1 million US to $2 million US. And if you need more than one of those to provide for a greater quantity of trucks on that line, then you can multiply that. Your actual trolley line itself, the poles and the wire, copper's very expensive, would you believe? That's another couple of $1 million. And that's before we get to mining an additional lane on your ramp. So instead of your typical 2-lane ramp, you're going to need a 3-lane ramp. I get lots of questions about this. I'm not aware of any 2-lane trolley ramps anywhere in the world. 3 lanes are used for safety reasons. If you've got trucks going onto the trolley at 20 k's an hour, where are your light vehicles, ancillary vehicles, and diesel trucks meant to travel, okay? It's not to say it can't be done, but I'm not aware of anywhere it's being done at the moment or has been done in the past. And in terms of construction, you're looking at least 3 months to build the physical infrastructure. And that's another reason you need that third lane. Although perhaps in Australia we wouldn't allow people to be working on installing a trolley line while you've got diesel trucks running up beside them. That's probably not really acceptable anymore. So it does result in a substantial production interruption to put that trolley line in. And you obviously need electric drive trucks, diesel electric trucks, not straight diesel trucks.
So that obviously limits you if you're an existing operation, and it can be like when you're looking at an existing operation, you've got to either switch out the entire fleet or wait for a replacement or not have all of your equipment.
That's right, and the other thing I forgot to mention is the physical pantograph and trolley box that needs to go onto the trucks as well. That's also more money, more weight. Pantographs are notoriously tricky. If the platform that the pantograph sits on isn't designed and built correctly, you can have all sorts of problems. So it sounds pretty easy, but it's not necessarily. Yeah.
And for BEVs, the charging.
I'm actually going to throw to someone in the audience who knows more about this than me. Cam Sharp from Caterpillar is kindly going to step in and give us some on-the-ground updates on what's happening up in the Pilbara.
Certainly, okay. Phil, to start with, I'm not so sure about your statement about trucks being removed from mining. I think there'll always be a place for trucks. And Sarah, the part you mentioned about the underground mining equipment, I forget the name of the companies you mentioned, but Caterpillar also have a battery electric underground loader called the R1700. So.
Yes, unfortunately it's not quite as big as the ones we like to use here in Australia.
Right, okay.
We're holding our breath for that.
Yes, right. Well, I just wanted to talk a little about what we're doing in this space, and we've got 2 battery electric 793 class trucks in West Australia now, going up into trials in the Pilbara with Rio Tinto and BHP. We're co-developing a lot of these battery electric machines with a group of companies called our early learners. That consists of Rio Tinto, BHP, Newmont, Valley, Tech Resources and Freeport on the 793 class trucks, and then Albemarle, CRH and Novamonde Graphite on a truck between 70 to 100 tonnes. We've got trials happening in various locations around the globe with some of these clients in hot conditions, cold conditions, wet underfoot. So we're looking to conduct trials in a range of different climatic conditions. We've developed a solution much like the trolley type system called our dynamic energy transfer rail. So these vehicles will be charging while moving during the trial assessments that are starting to take place now. This particular system you can install a kilometre of it in 2 days' time. It's very easy to move. We've been conducting a lot of trials and we've developed equipment to be able to make sure it's as flexible as possible and can be moved in as short a time period as possible. These battery electric trucks can also be used alongside diesel electric trucks, which can utilise the same rail. So we're making sure that we've got a lot of flexibility built into these product lines so that battery electric vehicles can be used in conjunction with existing fleet. We've also got a programme running at the moment called the Pathways to Sustainability. And it's a program where we're supporting some of our clients on their decarbonisation journey. And we're not ramming battery electric trucks down everybody's throat. If a mine's running from a grid connection from a big coal plant next door, going down the battery electric truck path's probably the worst route they could take. So we're looking at efficiencies with existing fleet and also looking at alternative fuel types, alongside some mines that really lend themselves to battery electric vehicles, dependent on the cleanliness of their grid connection or what their electric power consumption looks like. If you were to go down the battery electric truck path, it's potentially, as a rule of thumb, we say it's approximately 50% more power is required. It's probably going to be quite difficult to reach out to an electricity provider and say, instead of requiring 30 megawatts, I now need 60. a lot of electricity networks around the globe are quite constrained, so there may be supplementary power systems being built alongside grid connections, behind the meter, large-scale renewables as an example. But it's an exciting space, I see a huge amount of potential. Yes, there's a lot of upfront cost associated, but you've got to remember the OPEX costs that are associated with existing trucks. And, people say, well, batteries are expensive. Well, so is pouring fuel into them 3 times a day, or however many times it may be. Most likely these trucks are going to be autonomous because the amount of data set points that are required to be evaluated to determine how these trucks are charging and maintaining a reasonable state of charge is quite critical. But you remove the driver error, the driver fatigue, having to stop for lunch and toilet breaks. I see a huge amount of potential, reduced maintenance, and these vehicles can potentially be running 24/7. So the productivity aspects are quite attractive, I would say, moving forward. It changes it from a light capex, heavy OPEX play to a probably heavy capex, lighter OPEX play. So there's going to be various contracting models that are probably required to be looked at. But I see a huge amount of potential, obviously early stage, but I think over the next 10 years it's going to be quite exciting.
So before you go, Cam, can you tell us a bit more about the infrastructure that you've had to put in to support electric trucks?
When you start looking at what it does to a load profile on a mine site, it becomes very spiky, which is not very attractive when you look at conventional power generation, because you potentially have to run it with a lot of spinning reserve. You'd have to be running turbines, generator sets quite inefficiently. So it's really going to lend itself to large-scale energy storage or distributed energy storage to allow those peaks to be smoothed out, to allow whatever type of generation it is to be run more efficiently. Obviously, every mine site's different. Some have potential for wind, some can look at solar. I look at mine sites all over the globe. Some are in the jungles of Vietnam. Some have hydro connections. There's no silver bullet. There's a lot of different technologies are going to be required to support all our different clients' decarbonisation journeys from an electric power perspective. But I think there's going to be a huge rise in energy storage. Would be my thought.
Thanks, Cam. And for all the mining engineers in the room who didn't understand half of what Cam said, I've managed to figure out some of it in the last couple of years, and I'm sure you can too. It's pretty interesting.
Thanks, Cam. And maybe we just very quickly touch on the differences in infrastructure required underground for.
Oh, okay. Yep.
That's
I can take that. I think we all obviously know there will have to be some accommodation for battery swapping underground, particularly when you're looking at a shaft mine. Like, you can still run battery electric with a single dedicated access through your shaft. In sort of thinking through some of the challenges with how do you design the space to be able to enable the battery swap to be as quickly as possible. Those are some quite detailed thoughts that you have to have around cycle time, battery swapping, battery charging, where you store the battery to be charged, and what's the better configuration then as well for in the workplace. Do you want to be transporting a battery to the workplace for the loader to pick up and swap and then take it back to the charging location? Sounds a bit like double handling, but the real, I think, drag on a battery electric loader is it tramming around the workplace, with just itself to get to the next location. So, minimising some of that tramming distance and thinking through where you want the energy to be spent in the workplace and how you're going to store the batteries. Even the communications network at the moment. So I know everybody's using, LTE and that, what do we call, wireless communications underground. But knowing that this activity in particular needs some sort of monitoring or connectivity in order to acknowledge the hazard that's in the workplace. So we know that charging batteries can be hazardous. That's where your risk profile increases. That doesn't mean that it's still not manageable with the right controls in place. but making sure that you've got line of sight over how that battery's behaving in the workplace is going to be important, because the battery management system will look after all that. It'll tell you, how the battery's performing, and it probably gives you, more than ample time to be able to respond or react to a potential situation than you probably have in your mine at Current, where a CCTV camera starts, showing some cloud of smoke evolving in the corner. Then on top of that as well, I think Cameron, wasn't it? Yeah. Cameron was mentioning about how we set up our infrastructure to manage, that peak loading. That's one piece that we've been quite interested in trying to develop with a lot of energy providers. It's about the demand side, not the load side. So, that's the initial speed bump you got to get through when you're talking to your energy service provider, is they'll come back to you and say, yeah, well, you just tell us what the load is, and, we'll give it to you. We'll give you all the electrons you want. But what you want is something that manages that load demand side, so that you can get back to that nice, flat, even power requirement, either, however you want to call it, for the infrastructure on the surface to be to be operating at optimum. We've gotten really good at that, over the last, 30, 40, 50 years in mining. That set point for power requirement is we've done really well at, and now we're disrupting that by bringing in a bunch of gear that, we have to set our mind to be productive. So that means that the electrons have to be available when we need them.